In this video, we are going to be dealing with the West African Senior School Certificate Examination, Chemistry Paper 3, precisely a test of practical work. This is question number 3 of May-June 2011. I want to thank those of you who have taken your time to subscribe to my channel. And for those of you who haven't subscribed to my channel, please like this video, share to other learners, and take some time and subscribe to the channel so that you will be receiving other papers that we are solving. Yeah, thank you for taking your time to subscribe to our channel. Let's get started. We will be starting with question 3, application of concepts. Question 3 of May-June 2011. A. State one reagent. State one reagent with the necessary condition that can be used to distinguish between secondary alkanol and tertiary alkanol. Secondary alkanol and tertiary alkanol. Again, you have to state one reagent with necessary condition that can be used to distinguish between terminal alkyne and non-terminal alkyne. Each of them 2 marks, making a total of 4 marks. You don't have to write much, but just go to the point, state the reagent that can be used, state the reagent and then the necessary conditions, if available, that will be used to distinguish between this. So the reagents and the conditions are very, very important. The reagents and the conditions are very, very important. Let's go for A1. A1, that is one reagent with necessary conditions that can be used to distinguish between secondary alkanols and the tertiary alkanol. So the reagent and the necessary condition. So now, the reagent that can be used, to distinguish between secondary and tertiary alkanol. The reagent here is alkaline aqueous iodine. Alkaline aqueous iodine. Now, you know that this is the reaction. For the purpose of revision, I am giving you this. But in your question, you have been asked to give only the reagent and the necessary conditions. But all the writing I have given here is for the purpose of revision, for subsequent preparation for exams. Now, I said the reagent is alkaline aqueous iodine. This test, this is used for which test? This is a triiodoform test, or what we call the iodoform test. So the triiodoform test, or the triiodoform test, or the iodoform test, is used to identify the presence of the methyl, to identify the presence of this compound, CH3CHOH. That is a methyl group and a hydrogen atom on the same carbon bearing the OH group. This is the carbon atom that is having the OH group. The methyl group is still on the same carbon atom. So this test, the triiodoform test, or what we call the iodoform test, is used to identify the presence of the methyl group and a hydrogen atom on a carbon atom bearing the OH group. That is the purpose for this test. And in this test, the OH group is oxidized using the alkaline aqueous iodine. This is the alkaline aqueous iodine. So the OH group is oxidized using the alkaline aqueous iodine to corresponding carbonyl group. So it is oxidized to this, which then undergoes the triiodomethane reaction, resulting in a pale yellow precipitate of a triiodomethane or the iodoform, resulting in the triiodomethane or the iodoform. Once more, only secondary alkanols can undergo this reaction. I have given you this write-up in blue for revision purpose. It's not for the examination. It's not for the answer. It is for revision purpose. This test is used to identify a compound that contains a methyl group and a hydrogen on the same carbon atom bearing the OH group. And only secondary alkanols can undergo this type of reaction, the triiodomethane reaction. Only secondary alkanol can do that. So the reagent that was required is alkaline aqueous iodine. Okay, A2. That was 2 marks for the reagent alone. Then terminal alkyne and non-terminal alkyne. State one reagent. Just write the reagent with the necessary condition. That is what you are required. All the writing in blue I gave you was only for revision purpose. You don't need to state that in the exam. It's only for revision purpose. So the second one is A2. State one reagent. State one reagent with the necessary condition that can be used to distinguish between terminal alkyne and non-terminal alkyne. Okay. Now, for terminal alkyne, the reagent that is used for to distinguish between terminal and non-terminal alkyne is the reagent is ammoniacal silver nitrate solution, or what we call the Tollens reagent. Ammoniacal silver nitrate solution, or what we call the Tollens reagent. This is the reagent that is used to distinguish between the terminal and the non-terminal alkyne. That is the only reagent that can be used for that, to distinguish between the terminal and non-terminal alkyne. Then again, for the purpose of revision, the write-up in white is not required for the answer. The write-up in yellow is the answer. That is the answer. The write-up in white is only for the purpose of revision. Terminal alkyne react with Tollens reagent to form silver alkanides as a white precipitate, whereas non-terminal alkyne do not react with Tollens reagent. That is just all. I am giving you this for the purpose of revision. Don't include in your answer. Okay. Now, let's go to B. B is a total of 7 marks. B, what would be observed when each of the following salts is heated? When each of them is heated, we have sodium chloride crystals, we have trioxocarbonate 4 powder, and we also have sodium trioxocarbonate 4 decahydrate crystals. Okay. Now, the question, what will be observed? Give only your observation. On heating this crystal, what will you observe? Just what you need to state only the observation for the marks. Again, it should be 2 marks, 2 marks. only your observation, what is observed on heating each of the salts. Let's go to B1. On heating B1, 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 okay, B1. On heating sodium chloride crystals, B1. On heating sodium chloride crystals, a yellow color will be observed. That's all. Your observation is yellow color is observed. This is an indication of the presence of sodium ion in the crystals. Once more, on heating sodium chloride crystals, a yellow color will be observed. That's what you are supposed to state. Now, what I have written, this is an indication of the presence of sodium ion in the crystal is not required. It's not necessary. You can still write, but it's not necessary. We need it. The examiner needs only your observation. Then, B2, on heating zinc carbonate, which is a white powder. On heating zinc carbonate, which is a white powder, the color turns from white to yellow. The color turns from white to yellow. The color turns from white to yellow. That is just all. A white powder, on heating the white powder, it turns from white to yellow. This effervescence is not required. You will only observe this if if it was heated in a solution. If the white powder was dissolved in a solution, you will only observe effervescent bubbles of gas, indicating the release of carbon dioxide. Effervescent bubbles of gas or fizzing. You can only observe that if it was if the white powder was dissolved in solution. So it is not necessary. It is not necessary. The white powder is not necessary. So I mean the effervescence is not necessary. So what you can do is, say on heating zinc carbonate, which is a white powder, the color turns from white to yellow. That is just the only, this is what is required. Oh, sorry. Oh, yeah. Okay. I said it is from white to yellow, from white to yellow, from white to yellow. From white to yellow. So from white to yellow. So now, I said on heating zinc carbonate, which is a white powder, the color turns from white to yellow. That is B2. Then the other, from white to yellow. That was why I was indicating it. It's very, very important. Okay. Now, B3, on heating the sodium carbonate crystals. On heating the sodium carbonate crystals, it decomposes to give sodium oxide with evolution of a gas. It decomposes to give sodium carbonate with evolution of a gas. Decomposes. You can say it decomposes. Heating leads to decompose to give this an evolution of a gas. Okay, let's go to the other section of. Okay, C part. The C part outline the technique that could be used to purify a sample of potassium chloride contaminated with sand. That one is 4 marks. Outline the technique that could be used to purify a sample of potassium chloride contaminated with sand. That is a mixture of potassium chloride with sand. How can we obtain pure sample? How can we obtain pure sample of potassium chloride from a mixture of potassium chloride and sand? Okay, C. That is a separation technique. It's a separation technique. Separation of potassium chloride from sand mixture. How can we obtain pure samples of potassium chloride that has been mixed with sand? There are about four stages that are used for this. There is in dissolve. You have to dissolve it. You have to filter it. You wash the residue and you crystallize. There are 4 stages. So now, since they said the question say outline. Outline means you don't have to write much. Briefly, if you are someone who does not know who cannot summarize, I will advise you write the step, then you write the little that you can put there. Write the step, because what you are required to do here is briefly outline this. You put a dash, you write it. Another dash, you write it. Another dash, you write it. Step number 3, a dash, you write, and step number 4, you put a dash and write it. So in putting this, I give you mention the main point, and then you write the little that you can write. So in this case, I said the first point is dissolving. Dissolve the mixture of potassium chloride and sand in water in a beaker. Remember that potassium chloride will dissolve while sand remains. First step is dissolving. Dissolve the mixture of potassium chloride and sand in water in a beaker. Potassium chloride will dissolve while sand will remain. Step number 2, filtration. Using a filter paper and a funnel. Using a filter paper and a funnel. Filter the sand, and the potassium chloride solution passes into a conical flask. Step number 3, wash the residue. That is the residue that is left on the filter paper. When you filter it, since the potassium chloride solution passes into the conical flask, the residue will now be left on the filter paper. Wash the residue, that is the sand, on the filter paper with distilled water. Wash the residue on the filter paper with distilled water. Then the last stage is to crystallize. Crystallization. Under crystallization, we have heating, washing, and drying. So crystallization. The potassium chloride solution is then heated. That is the potassium chloride solution that has been filtered into the conical flask. We have not thrown away the residue. Only the solution of potassium chloride that is in the conical flask. We now say the potassium chloride solution is then heated to evaporate the water until crystals start forming on the glass rod. As you are heating the solution, you are turning it using a glass rod. So when you heat it to evaporate the water that is in the solution, it will get to a level that when you start finding crystals on the glass rod, that means it has arrived the level of saturation. The salt crystal should be washed with little distilled water and dried in a low oven to obtain a pure sample of potassium crystals. So precisely, if you can't do this, just know that dissolving, filtration, washing the residue on the filter paper with distilled water, and crystallization. There are 4 major points. When you do this, you will obtain pure crystals, pure sample of potassium chloride crystals. Okay, 3D1. 3D1. Give one use of each of the following pieces of apparatus. We have the spatula, we have the stereo, we have the crucible, we have the water bath, and we have the fume cupboard. You can call it fume cupboard or fume chamber. These are the different apparatus that are in the laboratory. How? Give one use of them. Just one. There are 5 of them, and each of the uses is 1 mark, making a total of 5 marks. So now, let's start with the spatula. A spatula, if you see a spatula is something like a spoon, a small spoon that is used. So laboratory spatula is used in transferring material, e.g., you transfer salt and other samples. I told you that if you go to the lab, a laboratory spatula is like a small spoon, a teaspoon. Some are like a teaspoon, some are not like a teaspoon, some are square. So we usually use it in transferring material, finish, e.g. salt, and other samples. It is also used for mixing. When you put it in you can mix different salt, or you can mix a salt and another chemical. So it is also used for mixing. It is also used for scraping, like what we mentioned, that the residue that was left on the residue that after filtration, the residue that was left on the filter paper in the question in our previous question, the residue that was left on the filter paper was scraped. You can use the spatula to scrape it. So it is used for transferring material. It is also used for mixing. It is also used for scraping, and it is and other related functions. Stirrer. Laboratory stirrer, such as a glass rod. A stirrer is something like a glass rod. Like when you were heating the solution, I told you in the previous question, when you are heating the solution in a beaker or in a conical flask, you are stirring it to make sure that there is uniform heating. And the type of stirrer that you usually use is the glass rod. We now say the lab stirrer, such as a glass rod, is used to stir a mixture and to ensure a uniform mixture. The mixture in a beaker, in a glass beaker, you use the glass rod in doing that. So it is used to stir a mixture and to ensure a uniform mixture. Okay, crucible. A crucible. A crucible is a C or a cup-shaped laboratory apparatus. This is how a crucible is. A crucible is something like this. It is something like this. Sorry. A crucible is something like this. You can do something like this. Something of that nature. So you can put something here. You can now put something here. You can put something here. Yeah. Then you can now maybe you cannot heat. You cannot heat. So I said a crucible. This is a CO, a cup-shaped lab apparatus used to contain chemical compounds when heating them to a very high temperature, like this. So you can use it like that. So it is a C or cup-shaped lab apparatus used to contain chemical compounds when heating them to a very high temperature. A water bath. A water bath. Water bath. This is a preferred heat source for heating flammable chemicals instead of using open flame. Okay, for instance, you might be doing something. Let's say this is a beaker. This is a beaker. You are heating it. This is a beaker. You are heating. Then the water we put here. The water we put here. Then you can now put your test tube. You cannot put your test tube. You cannot put your test tube here. Now, this water in this beaker here has a thermometer. It has a thermometer that is being used. It has a thermometer that is being used to control the temperature in this beaker. So we call this a water bath. A water in a beaker that has a controlled temperature. If you are doing an investigation that you need a particular temperature, you need to put water in a beaker, place it on a Bunsen burner, and then there must be a thermometer to regulate a particular temperature. So you can use that and put your test tube in the water here. So we call this setting here, the whole of the setting, we call it a water bath. So therefore we say this is a preferred heat source for heating flammable chemicals, because if you take flammable chemicals and you heat it directly on the Bunsen burner, it's going to be hazardous. So we don't heat flammable chemicals directly on the Bunsen burner. We will use a water bath in doing that. So I said it's a preferred heat source for heating flammable chemicals instead of using open flame. 2, it is also used to incubate samples at a constant temperature over a long period of time. As I mentioned, you need to put a thermometer there to maintain a particular temperature that you are working on. So those are the uses of a water bath. Then fume chamber. In other words, we can call it a fume cupboard. Fume chamber, or in other words, you can call it a fume cupboard. It's designed to capture and remove. It is designed to capture and remove airborne hazardous substances generated during laboratory experiments. It is designed to capture and remove airborne hazardous substances generated during lab experiments. Or you can say it is used to contain and exhaust chemicals, dust, microbes, powder, and other inhalational hazards. So that is what you can do. So that is all about this paper. If you can give all this, then you have 5 marks. So fellow learners, it is advisable for you to always go through laboratory apparatus and know their different functions, the role they play. In my previous video, there are a list of laboratory apparatus and their uses. So you can check on the Cameroon GCE or the Cambridge international exams videos. You will see some of them there, which I listed them out, and there are different functions. So this is all what you expected application of concepts. So once more, you know, you were told state. You don't need to write much. As I said, I wrote the green, but for revision purpose. So our reagent was just alkaline aqueous iodine. Then for the terminal alkyne and non-terminal alkyne, our reagent was just ammonium silver nitrate solution. Then the other one is for your revision purpose, to read and understand how the test is operated. Then we went into heating the different crystals, salts. So heating sodium chloride, heating zinc carbonate, and heating sodium carbonate. And you saw what was obtained. Then for outline, then for how to obtain pure sample of potassium chloride, I told you that there are 4 stages. You have dissolving, 2, filtration, 3, you need to wash the residue, and the last stage should be what we call crystallize or crystallization, which will mean it is heating, washing, and drying. That is crystallization. So if you can mention all those ones, that is a technique, a separation technique between sand and soluble and insoluble substances. Separation technique for a mixture of soluble and insoluble substances. So, and lastly, the different functions of laboratory apparatus. So thank you for this. We'll still be solving many more practical questions. Thank you. Thank you for that. Once more, for those of you who haven't subscribed to this channel, please like the video, share to others, especially those who will be sitting for the exam this academic year. And finally, take some time, subscribe to the channel so that all the questions we are solving here will come directly to you. Thank you very much.